Hey folks, in this video we're going to introduce the idea of a directed graph. This is going to be an extension of what we've already talked about, which is undirected graphs. So what have we been talking about so far in this course? We have basically these little pictures of graphs we've been drawing, for example the one on the left here. So this is what we've been kind of drawing up until now, right? This is a graph and there's just two nodes in it and there's an edge that connects them, right? This we're used to, right? This is what we call an undirected graph. If I have my two nodes here, right, and let's actually throw in a label on them real quick. If I have this as A and B, this picture here indicates that A is related to B and B is related to A. All is good. Now what we propose in this module is to change a little bit, add a little bit more detail, and add direction to the node. So let's look at the right hand side, right? So let's look over here. Notice I have a little bit of a difference in my picture because all of a sudden my edge now has this little arrow on it. And that arrow is basically going to indicate to me some sense of directionality. So in this case, if my nodes were basically labeled as A and B, what I would say is that A is related to B, right? The opposite relationship, right, B is related to A, isn't shown in this picture, right? So we're being a little bit more specific. Before it was back and forth, right? A is related to B, B is related to A, now only goes in one direction, right? So A is related to B. So that's what my little arrow though indicates, right? It indicates some directionality on my nodes, okay? So this is kind of our extension here as we go into this new module of content, right? As we're going to say that our edges now have directionality. And this will have some kind of interesting implications for us. It also have a lot of use, right? So there's a lot of real world problems, right, that maybe look more like directed graphs rather than undirected graphs. Okay, so this is overall what we're going to be looking at. So before we get into the technical stuff, let's just think for a moment what this kind of means to us. So I have here kind of two pictures, right? And I want to talk about a little bit about how maybe our intuition is impacted, right? So it's easy to kind of state the difference, right? I have a direction involved, but how does that impact us in practice? So I have two graphs here, right? So this is basically my undirected graph on this side, right? So this is undirected versus directed. Actually, I'm going to write this as digraph. That's kind of a common term, right? We'll say a directed graph is a digraph versus this over here. I mean, we can just write it as undirected graph. So yeah, so I have undirected on my left, directed on my right. And like looking at the one on the left, it's easy for me to, for example, check to see whether one node is linked to another node, right? And so, I mean, I can ask, is this one connected to this one? And you can instantly say yes, right? I can say, is this first one connected to this one over here? And you say yes, right? It only takes a glance. It's very intuitive to see that, well, I have a set of these nodes, and from any node, I can reach any other node, right? And it's very, very easy for me to do that. Let's try doing that on the other picture. So let's say I'm again asking the question, are two things connected? Well, I could ask, hey, what about this one and this one? Are these two connected? And it takes me a little bit more work because I have to actually inspect my edges. Now here, though, I guess it's not too bad for this first one because this first node, right, I can kind of see there's no arrows going on my endpoint. So hey, there's no way for me to get there in the end, right? So that's not going to work out for me. What about another one? What about if I wanted to know if this starting node over here, right, is connected to, well, let's go for the same one over here, this, right? Is anything connected to that? This one's a little bit more work, right? And let me see. I think this one is connected. You can see me. I didn't do this in advance, folks. So I gotta figure it out. I think it is connected. So let's see. That was connected to that one, but I think it's this root over here. I'm hoping that I don't. Yeah, there you go. That root over there. That's a lot more complicated, right? It took me a second to figure out. So I've kind of lost my easy intuition for connectivity, right? How are two things connected? Okay. So this is just something to keep in mind, right? Is that it's very we may become somehow too accustomed, right, to the fact that an undirected graph, right? As long as I see some sort of connectivity, right, it's like, well, I can get from there to there really easy. In directed graph, it's going to be different, right? So I can have my picture is very complex, right? I mean, there's tons of edges here, but I can't use them all, right? Because there's some sort of a direction that is required for me to take, right? If I want to have a path on this graph, right, I need to follow those arrows. Otherwise, right, it's not going to be a legitimate transfer, right? I can't go from one node to the other, right, unless that arrow points in the direction in which I'm traveling, okay? So yeah, so this is a big difference for us, right? It's just our intuition is going to be a little bit different. If you want to, right, you can maybe pick out a couple other pair of nodes, right? Try seeing if they're connected. And again, right, you'll see is it's super easy for that undirected case, but for directed case, right, we just have to think, right? It's a little bit more work. All right, so that's all I got for this video. Just kind of introducing the idea, right, that we're now going to move to directed graphs where all of a sudden all the edges have these arrows on there to indicate the directionality.